America ships more goods by rail than any other country in the world. For many shippers, SanteFe is the preferred carrier. It's a privilege we have earned by providing quality service over the years. Even as proud as we can be of our past service, fact is our industry is facing enormous challenges that places even greater demands on our daily performance. To remain competitive, we must constantly scrutinize every aspect of our service. For instance, freight damage. It does our customers little good if their products are delivered on time, but end up damaged upon delivery. Damaged freight costs us millions of dollars, and even more in lost revenue from customers who have found other ways to transport their goods.
When a car is loaded with paper, or a truck or a piggyback, that carrier becomes Champion International. You are representing the manufacturer. When it arrives at the other end and is damaged and unfit for a printing press, it is Champion who is called and said, your paper doesn't work on our press. And you have to believe that you are representing the manufacturer, that our business is your business. Because if we lose the business, the railroads will lose the business.
A significant amount of damage results from improper car handling, mostly from couplings that occur at speeds in excess of 4 miles per hour. Bad ordered cars sit in many of our yards waiting to be transloaded or repaired before they can continue to their final destination.
Behind me is a load of plywood that's been involved in an overspeed impact. The load has shifted towards the east end, tried to take the end wall out of the car. If you'll follow me, we'll take a look at the handbrake, which is out of compliance. It's going to necessitate this entire car being transferred before it can move to its destination. The end wall is very severely damaged, being pushed out by the load inside. No doubt some of the plywood inside is damaged and will be rejected by our customer.
So, you might argue, a few cars do get damaged along the way. But why don't customers acknowledge the thousands of cars we handle daily that don't get damaged?
You have to measure that against our expectations. You know, as the expectations of our customers for quality products have risen, our expectations of the transportation industry have risen right along with it. If we've devoted millions of dollars to building a high-quality product at the factory, we want to get it to the customer in the same condition it left the factory. And it really doesn't matter whether it's a 10% problem or a 1% problem. Any damage is too much.
The fact is that all damage from overspeed incidents is preventable. It's partly an issue of efficiency, switching cars as little as possible, and partly an issue of carefully handling each car when we do move them. ECHO, Efficient Car Handling Operations, is one way SanteFe is addressing car handling. It's a volunteer program that routinely monitors every aspect of our operations and measures our successes and failures. ECHO was introduced in 1976, but is being renewed today with an important challenge: to monitor every aspect of car handling on the system, from switch yards to in-train movement. SanteFe's Careful Car Handling program has several aspects that will be explored in this video. First, ECHO is primarily an awareness program. Customers expect no damage to their products. One way to meet this need is to couple all rail cars under 4 miles per hour. ECHO is interdisciplinary. All departments must work together to meet customer expectations. ECHO is local. Local teams will establish formal monitoring procedures specific to each yard or location in our system. ECHO is a volunteer program. ECHO is not just about doing your job, it's about doing your job well.
ECHO meets customer needs.
To better serve our customers, we have fundamentally changed the way we do business. Today we do more pre-blocking at origin and block swapping en route, which further reduces the amount of switching. We do less flat switching and more shove-to-rest couplings to further protect freight. We operate more dedicated intermodal trains and unit grain and coal trains. Most intermodal traffic now moves on articulated cars, further reducing slack action forces. As a result of these and other changes, we have become a more competitive railroad. That doesn't mean we can afford to lose sight of our customers.
We're in a much more competitive environment than what we were before. And what we need to do is offer service that's good service, not just fast service.
ECHO is customer awareness.
We often think of these cars as box cars, trailers, tank cars, covered hoppers, or autoveyors. They seem
Employees are car purchasers, so think about the experience they would like their own personal vehicle to have had during the transportation cycle. And I think they would conclude that they want the people handling the product to be extremely careful with it all the time.
we must remain focused on many of our most basic operating procedures that are sometimes easy to forget when pressed for time. Procedures like coupling cars at 4 miles per hour or less. This has been a long-standing operating rule. Why? The AAR has conducted many impact tests on all types of cars and freight, and they have determined that impacts at 4 miles an hour or less pose no appreciable risk to most products and rail equipment.
Impact speed was 8.3 miles per hour.
Actual speed, 6.2 miles per hour. Actual speed, 6.2 miles per hour.
Our customers spend a great deal of their resources preparing for the physical forces that occur during transportation.
Well, the shipping process actually starts with the load planner at the time the order is entered into our computer. At that time, based on the width of the roll and the diameter of the roll and the weight of the order, the load planner will come up with a load plan. We probably have generated 600 variations of the load diagram based on car width and length, roll diameter, and the weight of the rolls. And many of those are approved by the Association of American Railroads.
When a car loader is loading a car, it loads it tight, eliminates all the void space from one end to the other, and no matter what his best efforts, he's always going to have a gap in the doorway. A DID bag, a disposable inflatable dunnage bag, is designed to take up that space, and it's inflated to about 8 psi, and large bags can literally push the rolls even tighter than the car loader had packed them, and that'll take up the space and make for a more solid load as the car moves down the track.
Customers often design their products with shipping in mind.
Our engineers are aware of the parameters of the rail equipment, and they work within that environment, and we also have an extensive in-house testing program where we have a rail car ride simulator that we test all our new products on the simulator well in advance of production.
The auto industry has also seen evolutionary changes in railcar designs to help reduce damage. Today it is common to see fully enclosed autoveyors to prevent lading damage, thefts, and vandalism. Manufacturers are adding protective guards and materials to the exterior of the product to further reduce chips and scratches. Still, problems persist.
It doesn't matter to the customer if they have a problem with the vehicle, whether it's a result of something that happened in transportation, for example, squeaks and rattles, or whether it came that way out of the factory. The customer doesn't know and doesn't care. They just know they're not happy with the product. So we are working very hard to make sure nothing happens to the product in the transit cycle.
Because a boxcar is a boxcar is a boxcar and there's not a tag on the outside, all boxcars have to be treated the same. And today they are. They're shoveled around at whatever speed the switch yard or the switch crew is operating at that day. And it has to be an industry-wide effort to slow up those operations to get them all under 4 miles an hour. And that probably happens only about 70% of the time on American railroads. Speeds higher than that occur 30% of the time. And for small percentages, that coupling speed is over 8 miles an hour. And at that speed, just about any load will come apart.
Customers know us very well. They study our yards, our switching practices, and they know the best ways to ship through or around us.
We're very selective in the routes we use and the carriers that we contract with. And so we do a competitive analysis of the different railroads, and their quality performance is a very key factor in deciding who gets the business.
ECHO is interdisciplinary.
Volunteer committees from all operating departments work to find ways to improve operations. These are local teams that understand the operating conditions of their facilities and work together to make improvement.
3.8.
Why local involvement?
They have the quickest solution. They're the people that deal day in, day out with the various operations of their yard. They know, and I think they're the quickest one to find the solution to the problem. And they've got a lot of good input.
The primary goal of the ECHO program is to eliminate all overspeed impacts. Local committees are being formed to operate self-monitoring programs in flat switching yards and hump yards to make sure we handle cars at 4 miles per hour or less.
ECHO monitors switch and hump yards.
We go out and once a month we take the radar gun and then set it up and monitor all the guys as they're doing their switching. We're not out here just for 15 to 20 minutes doing it, and we're getting a large sample. We're trying to get approximately 10% of the shipment that goes through here. And to get 10%, we can do that in 2 to 6 days. And we monitor the crews. We random pick a crew and just go out and set it up and see how he's doing. See if he's kicking the cars when he flat switch and keeping them under 4 miles an hour. And if he's not, we try to educate him and tell him everything under 4 is damage-free freight.
On the hump, of course, what we're doing is classifying cars automatically, letting the computer in each hump tower handle the cars over the hill. It's a matter of basic physics that measures the mass of the car, it measures the rolling capabilities of the car, and decides how fast the cars should be coming out of a specific location in order to make a joint of 4 miles an hour. The hump maintainers are going to depend on the readings that we get with the radar guns and seeing what the actual coupling speeds are in order to calibrate their equipment as far as the retarders.
And then we can take the echo readings with the radar, compare it against what computer has said that he has coupled them at, and then look for faults and correct those faults and constantly upgrade with the changing temperatures and weather conditions. And it helps us to get the reviews from ECHO so that we can see when we are beginning to vary.
We turn our audits into quality control. They analyze them and they present them to the shippers as to what we're doing and showing the shippers that we are committed to protecting their goods.
We want hard copy proof of performance. Every quality program says you must be able to measure how something is operating, how a process is performing. And we believe in measurement. We are going to plot that information against the switch yards. We are going to pick routes that car handling is good on, and we're going to avoid or try to avoid those routes where paper is mishandled in boxcars.